Hello everyone. Now we shall work on the experiment number 5, which is 8:1 multiplexer. I'll read out the question. Given a 4-variable logic expression, simplify it using appropriate technique and realize the simplified logic expression using 8:1 multiplexer IC and implement the same in HDL. That is software part. We'll concentrate on the hardware part. To conduct this experiment, we need IC 74151. It is a 16-pin IC. The pinout diagram is given in the manual. Referring to this IC diagram, you are going to make connections later. Usually, they'll give problems to solve this multiplexer, and then you need to connect based on what type of problem you have got. So, in this manual, they have given the problem f of ABCD, that is equal to sigma of min terms 2, 3, 4, 5, 13, 15 plus don't care 8, 9, 10, 11. I guess you are familiar with such type of problems. So many problems are solved in online classes in theory and lab. And you should be familiar with MEV map method by now, right? So this is how you can solve the MEV method. MEV method helps us to reduce the number of inputs. Suppose you are taking 16 inputs, you can reduce it to 8 inputs. Suppose you are taking 4 inputs, you can reduce it to 2 inputs. So this is the MEV map. I told you it is not the same as K map, it is a MEV map that is used for multiplexer. And this is how you need to write. This is already taught in your classes. And you have to see that if both the cells have 0, the result is 0. If both the cells have 1, the result is 1. So if both the cells are 1, the result is 1. Suppose 0 is there in one cell and 1 is there in one cell, you have to see what is there in the row, particular row. This row stands for D bar and this stands for D. So this will be D. Okay. Then suppose you have 1 here and 0 here in case, then you have to take D bar. But in this particular example, we are not getting D bar, we are getting only D. Okay. So this is MEV map representation. The other way also you can represent the map. This way also we have solved problems in the class. Here clearly we are indicating how the 16 input is reduced to 8 input. By MEV rule we know that we need to group it, right? 0, 1 I am making it as one group, 2, 3 I am making it as one group. Okay. Okay. Then we are having the function, whatever the function that is there, we need to write here. Whatever the function that is there, we need to write here. So write the minterms, wherever the minterms are there, put ones. Wherever the minterms are not there, put zeros. And wherever the don't cares are mentioned, put don't care. Put don't care. Okay. So then based on the MEV rule, you have already done grouping. If both are zeros, you have to put zeros. If both are ones, you have to put 1. Okay, if both are don't cares, you have to put don't care. I have told you the rules that you have to follow for MEV in classes. Okay, and this is the final circuit diagram what you are going to get. This is the circuit diagram. This circuit diagram is different for different problems. Don't think that this is the same circuit diagram for any problem. It all depends on what function is given. Okay, so for this particular function, you can observe that here D naught is 0. Okay. Suppose you take this as D naught, D1, D2, D3, D4, D5, D6, D7. So D naught, okay, D3, they are 0. So based on that, you have to make the connections D naught and D3 of the IC. Don't get confused with the pin numbers and the IC pinout diagrams, these numbers, okay. So D naught and D3 of this should be connected to 0. Short it and connect it to 0. Okay, I'll show you how to do. And then wherever the ones are there, say here we are getting D1, this is, if you take this as D1, D2, okay, say I'll write it down, I'll not get confused. I'll take it as, say, this is D0, D1, D2, D3, D4, D5, D6, D7. Okay, you will not be confused if you write like this. So D1 and D2, D4, D5, you have to connect them together and connect it to high. Okay, and as I told, D0 and D3, you have to connect it together and connect it to low. And D6 and D7 connected together, it forms D input, that is the fourth input. Okay, so let us see how we can connect it using the IC. We shall take the IC here. I told you that the notch should come upside. So place the IC. It's a 16 pin IC, so it covers all the pins. So it is 1, 2, so like the circuit in the trainer kit. So we can see that the pin number 4 and pin number 1 is connected to 0 according to the MEV result what we got. So I will connect it, pin number 4 and pin number 1. So I'll short it, pin number 1 and pin number 4. I'll short it and I'll connect it to one of the inputs and I'll keep it low. We should keep it low. Then we'll see which are the pins we need to connect to high. That is pin number 3, pin number 2, pin number 1. Sorry, pin number 3, 2, 14 and 15 should be connected to high. So we'll take pin number 3 to 2, then pin number 3 to 2 I have done. So from 3 or 2 you will take to pin number 14, that is this is 7, 8, 9, 10, 11, 12, 13, 14. So this is pin number 14 and 14 to 15, 14 to 15, this is 15 and that should be connected to the input and should be given high. Okay, then you have to short pin number 13 and 12, that forms D. So this is 8, 9, 10, 11, 12, 13. So pin number 12 and 13 we will short it and then we will give it to the output, that is input, this is D. I will give here D. Then next 7 is ground, 7 is ground, so this one pin number 7 I am connecting it to ground and pin number 8 is also ground. Okay, so I am connecting pin number 8 also to ground. Okay, and then pin number 5 is output, that is 1, 2, 3, 4, 5, that is pin number 5 is output. Connect to any one of the output pins here, and we have already done with D and we have to do with ABC, the select pins. So pin number C is 11, that is pin number 11 is C, so that is 8, 9, 10, 11, this is 11. So this is C, I am connecting next to D. Okay, and the next one is pin number 10 is B, pin number 10 is B. 1 second. Pin number 10, that is 8, 9, 10. Okay, that is D. I am connecting next to C, and then pin number 9, that is 8, 9, that is A. This is A. So now I have in this order D, C, B, A, and this is 0 and this is 1. Okay, and this is the output. Only one line is given to output, that is from pin number 5. Not done the VCC connection, we will connect it. The VCC connection is given to pin number 16. So now we shall power on the trainer kit and we'll see how it works. And I told you that one of the input, that is that it should be set to 0 and the other one is set to 1. This 0 and 1, that is done here. All the wires that has to be connected to 1, it is done here. All the wires that has to be connected to 0, it is done here. Then this is in the order D, C, B, A. It is in that order, D, C, B, A. So this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. D, C, B, A. Okay. This order is very important to see the output. Many times what happens, you are good in connection, you have done everything well, but if this order doesn't work well, then you cannot get the proper output. So remember, you have to keep a proper order for this, that is D, C, B, A. Okay. So now we'll see the output. How to see the output? It's nothing but you have to see the values that is given in the function, min terms that is given in the function. If you give 2 as input, okay, the LED should glow because that min term is present. Okay. If I give 3, 2 plus 1 is 3, the D and C are on, then also it is 1. Then if it is 4, it is on. So for all the min terms that are present in this sigma m, the LED should glow. And let us check for don't care. Since don't care we have taken it as 1, we will see. I'll give 8 as input. It is glowing because we have taken it as 1. Okay. And 9, that is the last one, should be high, and this one should be high. MSB and LSB, they are high, so the LED is glowing. Suppose if I give any of the inputs that are not mentioned in this function, say 0 is not mentioned in that function, I'll make all the inputs, that is DC, BA to 0, then you can see that LED is not glowing. You give some other input, say 1 is not mentioned in this function, so the LED is not glowing. So this is how the 8:1 multiplexer works. You can try it with different functions. For different functions you will get different maps and different circuit diagram. It's unique for each and every function, this circuit diagram. Don't think that the same circuit diagram works out for all the problems. Thank you.